Here we will look at examples about vector addition. Here we have an example. We have vectors with magnitude and direction as shown in the figure. You are to determine the sum of these vectors or find the resultant vector using graphical method tail to tip. To do this, we simply put the tail of the first vector A at the center of a Cartesian coordinate system. We then connect the tail of the second vector B to the head of the first vector A. Then we connect the tail of the first vector A to the head of the first vector B. Here we have another example. Here we have vectors with magnitude and direction as shown in the figure. You are to determine the sum of these vectors or find the resultant vector using a vector component or mathematical method. Graphically we can show it, but this time we approach it using a mathematical method or the vector component. So, we examine the components of each vector and add them along a similar axis. First we look at vector A and separate it based on the components. For the x component we use the cosine function to obtain an expression using the component A along x. So using equation 1, which is a cosine function, will give us equation 2, which shows an expression for the component of x but gives only the magnitude. We rewrite scalar equation 2 to incorporate the direction, so we have an expression that is a vector form of the component along x as shown in equation 3. So the direction is given by the unit vector, which is a negative I hat, since it is oriented towards the negative x-axis as shown in the figure. Now we examine the component along the y-axis and we see that we need a sine function in order to get an expression that contains the y component of A, and it is given as equation 5. We then obtain equation 6, which is the scalar equation for the y component magnitude. We rewrite scalar equation 6 to incorporate the direction, so we have an expression that is a vector form of the component along y as shown in equation 7. After substituting the values, we get that the y component of A is given in equation 8, which is a positive value of 1 along the y-axis. Now we examine the second vector and its components. Clearly, it has no component along the y-axis, so we can just set it to 0 j hat as shown in equation 9. The x component then is just equal to 4 I hat as shown in equation 10. We then add the vector components of A and B and it is summarized in the table. Here we obtain the vector components of the resultant as r of x and r of y. We then plot the resultant vector using the components and we see that it is indeed positioned in the first quadrant as suggested by the positive values of its components. Using Pythagorean theorem we can obtain the magnitude of the resultant and it is given by equation 11. Manipulating the equation we get the magnitude of the resultant vector shown in equation 12. Now we then determine the direction of the resultant vector and we can use the components and the tangent function. Using equation 13, which is the ratio of the opposite length over the adjacent. So for the angle gamma this would be r of y over r of x. So the position of the resultant is given in equation 14 both in degree and radian mode, and it is measured with respect to the positive x-axis. The resultant vector is measured using the component method or mathematical method and it is given as equation 12 and equation 14. Comparing this process with the graphical method, I would say that it is far more reliable in terms of reduced error. Here we have an example where we have vectors as shown in the figure. They have the same magnitude but oriented differently. Determine the resultant vector using vector component or mathematical method. Let us consider the first vector A and we see it has no y component and its components are given as shown in equation 15 and 16. For the second vector b where it has no y component also but it oriented in the negative direction along x. We see the components for the second vector shown in equation 17 and 18. Now we look at the third vector and it has no x component and it is reflected in its components in equations 19 and 20. The last vector d has no x component also but it is oriented in the negative direction as shown in equation 21 and 22. We then tabulate vector components and it is shown here. For the x component we are left with vectors a and b and since they have same magnitude and this results to 0 value for the x component of the resultant. This is the same case for the y component which results to 0. So the resultant vector is 0 as shown in equation 23. The end for now. For questions and comments you may send them to diyeslearningstuff@gmail.com. You may review the slide on YouTube at @dieslearningstuff. Note, please do not forget to use your school email. Also write your complete name and class section. Thank you for listening and see you next module. The end for now.